Hello everyone, this is Neil from Edureka and welcome to this IoT tutorial session. Now IoT or Internet of Things as it's most popularly known is one of the greatest phenomena of this century. It's gained a lot of popularity and in today's session we'll be getting a brief idea of what IoT is and we'll also be working on a demo using Raspberry Pi. Now going on to the agenda for this session, we'll start off by first understanding what is Internet of Things and then we'll try to address the question why do we need Internet of Things. Going on from there, we'll talk about the various benefits of IoT as well as the various features of IoT as well. And finally, we'll be moving on to the demo of this session, which is basically creating a weather station using Raspberry Pi. We'll mainly be measuring three things. We'll be checking the temperature of the environment, the pressure, as well as the humidity present. Okay, so these are the three things that we'll be measuring using Raspberry Pi and another component known as Sensat. Okay, so moving forward, let's talk about the first topic of this session, which is what is Internet of Things. Now, to help you understand what is Internet of Things, let's look at an example of our mobile phones first. Okay, our mobile phones has GPS tracking. It also has mobile gyroscope. You have adaptive brightness, which gets adjusted based on the light falling on it. You have voice recognition, and you also have face detection, which identifies who is the user. Now again, iPhone X is coming with face detection. So again, these are a lot of features that are coming pre-built on the mobile as such. And most of these have a common interaction between them because let's say one application can use all of these features. I can also have these features in itself being interacting with each other. Let's say based on a GPS location, my brightness could be adjusted, or based on the direction my phone is being held, the brightness in itself can also be adjusted as well. So there are a lot of features, but when they interact with each other, these features come together to bring in a better system than anything that they can provide individually as such. That's what Internet of Things is. It basically is a platform wherein we can connect everyday things which are embedded with either electronics, software or sensors to the internet, and this in turn enables us to collect as well as exchange between these things. Now when I say things, it can be anything and everything. Let's say I have an internet platform wherein I can connect these things. If I take the example of my house, I can connect my lock, I can connect my AC, I can connect my lights, and all this can be managed on the same platform. Now since I have a platform itself, I can also connect my car to this. I can keep a track of my fuel meter, I can keep a track of my speed limit, I can also keep track of the location of the car as well. Now if there's a collective platform where all of these are connected, wouldn't it be great? Because I would love to have the AC on and set a cool temperature at my home by the time I reach back from office. If I have a platform that knows my preference and that keeps track of where I am and where I'm going to, then it can also identify that I'm going from work back to home, and my preference suggests that it would be best if there was an AC temperature of about 22 or 23 degrees centigrade. And this is something that is definitely possible through Internet of Things. Now this is just one of the examples. Now let's say tomorrow you come back home. It would be great if I wouldn't even need a key to unlock my door. My home system should be aware that I have come home and it should unlock all the doors that are needed. And now this can be done if my mobile and my home devices are connected onto the same platform. Based on the location of my mobile, it can identify that I am at my home. So it will automatically unlock the door and let me come in as well. These are some of the real world implications of Internet of Things. These are something that are already happening. But going forward, what we need to understand is that when I have a specific component with me which can do a lot individually, wouldn't it be great if I can collaborate this component with my system of different components and build a better system? This is what Internet of Things is helping us do. Okay, you provide a platform through which all these things are connected through the internet. So internet becomes the medium through which you're connecting all these components or things to a platform. Okay, moving forward, let's try to understand why do we need Internet of Things. Now to help you understand why, let's look at an example. There's a patient at home. Okay, he's on constant life support wherein his status is being checked to a health monitoring system present on the cloud. Let's say at a point there is certain issue with respect to his health. Let's say there's some irregularity with his heartbeat or his blood pressure is low, there's some fluid being developed or so forth. Now what happens is, since the system on the cloud is connected to a hospital as well, this information would get passed on to the hospital as well. Therein what would happen is that they would get the complete details with respect to the patient and the important information with respect to the current situation of the patient as well. We made it aware with respect to what issue exactly is the patient facing, as well as enable them to dispatch an ambulance immediately to bring the patient back to the hospital as well. Now, meanwhile, once the patient has been picked up and brought back to the hospital, there could be prescriptions, there could be medicine, there could also be an operating theater made ready in case of an emergency situation as well. There'd be doctors on standby who have the complete history of the patient, who have the complete details of the present condition of the patient as well. So this in turn brings in a lot of transparency and reduces a lot of effort and time involved with respect to this. Same thing, let's take in today's scenario. There has to be someone monitoring this patient's health. And if there's a fluctuation, they need to call the hospital, they need to call request for an ambulance. And meanwhile, once the ambulance is here, they take the patient and they're back into the hospital. Then again, there needs to be a lot of checkups that need to be done because the doctors are not fully aware. Again, there is a lot of tests that need to be run, and this in turn leads a lot of delay as well in certain emergency cases as such. Now, if a system can do this, then this is exactly where our future lies in and what we have to definitely move forward to. Now, Internet of Things basically is expanding the interdependence of humans to interact, contribute, and collaborate with things around us. Now, what do I mean by interdependence of humans? How we depend on each other. Like how I'm explaining this concept to you. If you're not clear, you would reach back to me, you would request me for help. Okay, this becomes an interdependence between us. When I'm giving you knowledge, when you're not clear, you're coming back to me and you're helping. Similarly, tomorrow, if there's something that you can do for me, I would reach out to you. So we all are interdependent on each other for something or the other. If we can expand this interdependence to interact, collaborate, and contribute with respect to the different things around us, then we would be building a proper Internet of Things environment. This would be a much more safer, secure, effortless, and time-saving environment in existence. Moving forward, let's talk about the various benefits of Internet of Things. Now, the first thing that would be as a benefit of having an Internet of Things platform would that it would efficiently utilize the resources that are available. If I have a smart system which can interact with everything, if it has enough computational power, if it has enough understanding of how things work between each other, I'm quite sure the usage of the resources available will be more efficient as well. This resource could be in terms of monetary, it could be in terms of natural resource, it could also be an input taken up by the thing as an input and so forth. Okay, so all this can be more efficient if I have a platform which is more smarter and interconnected as well. Apart from this, it minimizes the human effort involved. If my system is smart enough to interact, if it is smart enough to do things that I don't need to get involved with, then my interaction is always going to be minimal. This is the same with everyone. And that's one of the major reasons why Internet of Things has become popular today. And the concept of smart home is always growing as well in the same perspective. Because if the system in itself is able to do most of my work at home, then I don't need to put in much effort. I can relax at home without having to worry about anything. Okay, the next benefit would be it saves time. If it reduces my human effort, definitely it is going to save my time. Okay, apart from that, if the resources are utilized more efficiently, then again it is going to save a lot more time as well. All in all, any benefit of Internet of Things will in turn help you save a lot of time as well. Okay, so time is one of the major factors that can be saved on an Internet of Things platform. Now, if I have an artificial intelligence platform through which all of this is managed and maintained, then the personalization and the human touch also comes into the picture. Now, today most of us have had a level of interaction with an artificial intelligence or a virtual intelligence as well. This could be a personal assistant like Siri, or it could be an assistance application like Google Assist. Now, if I have a system where all these components and things are interconnected, then in turn all the security present on each of these things is going to get multiplied and it's going to build a much more secure system. Apart from that, the level of security that you would be integrating to the platform in itself is going to be quite huge. So the overall security with respect to everything is going to increase multiple times as well. Now let's look at some of the major features of Internet of Things. Now, any technology that is available today has not reached its 100% capabilities, and it always has that gap to grow. Internet of Things is one of the major technologies in the world today that can help any other technology reach its true and complete potential as well. Now there are mainly three aspects to Internet of Things as to how it works. First is the connect aspect. Here basically what you need to work on is you need to ensure that there's a connectivity between all the things around you, all the necessary things to the Internet of Things platform. Okay, then comes analyze. Now I have my things around me, they each are going to generate some amount of data. Now this data needs to be collected and it needs to be analyzed to build a business intelligence solution. If I have a good insight from the data that is gathered from all of this, then definitely I can call my system as a smart system. Finally, what happens is, in order to improvise and improve your system, you need to integrate it with various models to improve the user's experience as well. Let's say there's a personalization module that is there, or let's say there's going to be an aspect wherein I can directly connect to my providers. Now this provider could be Amazon, it could be Flipkart, it could also be my retail store that is next to me. Let's say I'm out of milk, the retail store would get a notification and he would send milk right away. And the same thing can be done. Let's say my coffee machine requires special beans and this beans is almost complete. Then what my system could do is it could go online to Amazon and purchase these beans for me as well. So there are a lot of things that I can do when I integrate this with respect to various models and improve the overall experience to a single user or a group of users or the world itself as such. Okay, now let's talk about each one of them one by one. Let's start with connect. Now the first stage of connect is device virtualization, because what you need to first do is that you need to standardize the integration of the device to the enterprise platform which is present on the cloud. Okay, now it could be present on a cloud, it could be present on a server, but again it's all going to be connected through the internet. So what I need to do is that I need to ensure that certain level of standard is present on the device so that it can go on and connect to my Internet of Things platform. Now to help you understand this better, there could be a standard power plug and there could be a power plug which has an inbuilt Wi-Fi support so that it can connect to my lab. Now to build a smart home system, I need the second power point, because there only I would have the access to control it over the internet and my system could integrate with respect to the same. Okay, now if I take the first standard power point, then what would happen is that I need to manually switch it on and switch it off. However, in the second case, I could send a signal to it and this in turn will switch it on and switch it off. So there's supposed to be a level of standardization through which I can integrate all of these devices to my platform. Next comes high-speed messaging. So now what I have done is that I have connected all these devices to my platform. But these devices in turn generate a lot of data, and this data is what is going to help us understand better on how we can improve the overall system and help and provide the user with better experience. So for that we need to have high-speed messaging. Okay, this basically means that there needs to be a reliable, secure and a bidirectional communication channel between the devices and the platform. Now the purpose of it being bidirectional is because you need to control each one of them as well. Let's say I want to switch on the AC, then the signal would be going on from the cloud platform to the device. So this is how it works on. Okay, so every communication needs to be reliable, it needs to be secure, and it needs to be bidirectional as well. Moving on to the third point of connect, you need to have endpoint management. If I don't have an endpoint management, I have established a way through which all my devices can connect to my platform. I've also ensured that the data is going to be sent from the device to the cloud and the cloud can send back to the device as well through a secure channel. But if I don't actually identify from which device which data is coming and how this data has to be processed, then it becomes a failure of the system. This is where endpoint management comes into picture. Endpoint management basically helps you in managing the device's endpoint identity, the metadata, and the overall life cycle involved with respect to these things as such. Okay, so to put it quite simply, it basically helps you identify from which device which data is coming and what needs to be done with this data as well. Now coming on to the next feature is analyze, and the first thing that you need to do for analysis is the stream processing. Now if the data coming from the device is not on a real-time basis, then my system is of no use. There's no use if I tell my system to switch on the AC at my home and by the time I reach there, if the AC is not even turned on, then it's a failure on my system. Okay, so real-time analysis of the incoming and outgoing data must be done with respect to different aggregations, filtering, correlations, processing, and so forth. Okay. Now apart from this, what you need to do is that this is raw data that is being streamed from all the things. You need to identify which is contextually important information which is going to be taken forward. So once I have the relevant information, then I can even generate composite streams of information which can be taken ahead for future analysis and understanding as well. Now this is what your data enrichment process does. Then you have event store. Now in event store, basically any information that you want can be queried and visualized from the vast amount of data which is present on my cloud platform. Okay. Now this in turn can also help me get a better insight and analysis. If I have all the enriched data present on my cloud platform, I have a tool which helps me identify what is needed, helps me analyze this data, helps me visualize it, then definitely it becomes more useful as well. And when I have data coming from different things as such, this in turn can also lead to being a collection of big data. Now, when I talk about big data, it's not just few GB of data, it's going to be terabytes of data because the data generated from the things around us is that vast. And if you're doing it over a period of time, then definitely it is going to grow into a big data domain as well. Now, coming to the third feature of Internet of Things comes enterprise connectivity. So this is what I was basically telling you about. Let's say I have a requirement from my retailer or even an enterprise organization which is present. It could be Amazon, it could be Flipkart, anything as such, any enterprise organization which provides me a service. If I can connect to them through this platform, then definitely my overall process also becomes easier as well. Let's say there's a service provider. Okay, let's say there's a leakage in my plumbing, or let's say there's some issue with respect to my electricity. Then it can contact to the corresponding service provider, it can send them a detail, and correspondingly they would be dispatched. This would in turn reduce my effort of having to check the problem, having to call someone, wait for them to come back. All that gets reduced to minimal required effort as well. Now, how does this communication happen? So for that we have REST API. Okay, once I've integrated my REST API with respect to the cloud application and my Internet of Things, then communication between the enterprise, communication between the platform, and the communication between the things around us can be made more efficient and can be more easy as well. Now, the third aspect is command and control. If I don't have command and control on my platform, then it's of no use. Yes, I build a very great environment, I build something that's quite extraordinary, but if I cannot command it, if I cannot control it as per my requirement, then the system in itself is not useful. If I cannot tell my door in a smart home to unlock when I want it, then it becomes failure on my part. If I cannot control the AC on my smart home, then again it's a failure. So always the major aspect when you integrate with respect to these things, the major thing is that you need to ensure there's a huge control on the system and you're able to command it as per your requirement. Now this command could either be through a voice-based recognition, it could also be a message that you can send through your mobile application and so forth as well. Okay, so now let's start with the Raspberry Pi OS installation. I'll help you understand how you can actually install Raspberry Pi operating system once you've bought the Raspberry Pi. Okay, so we'll divide it into different parts. First, let me help you understand the different operating systems that are available at present. Okay, Raspberry Pi in itself supports multiple operating systems as such, but we'll mainly be working on Raspbian. Okay, so these are some of the most popular operating systems supported on Raspberry Pi. So you have RIS OS, you have FreeBSD operating system, you have NetBSD operating system. Plan 9 is again from Bell Labs, as well as Windows has its own Windows 10 of IoT version. Okay, so for this session we're not going to go into the Windows 10, we'll stick to the core Raspberry Pi operating system. Now for downloading the operating system, you can go on to the original site, that is raspberrypi.org, and there in the downloads tab you can download the operating system. Let me just show it to you. Okay, so this is the Raspberry Pi homepage, and here if you go on to the download section, you can download the operating system. Now if you are starting off with Raspberry Pi and Internet of Things, trust me, this is the best place that you can find a lot of information with respect to it. Okay, most people actually publish their details with respect to the projects that they're working. Many popular projects are also available. You can find a lot of help as well as good information here. Okay, so this is definitely the place to go to. If you go on to the download section here, okay, this will either show you two options. You have Noobs or you have Raspbian. I would recommend that you go with Noobs because this is a complete package with respect to the different operating systems as such. So here again you have Noobs and Noobs Lite. So my recommendation would be you download Noobs and make sure you're using a 32 GB memory card. Okay, this would be really helpful because it gives a lot of memory for your operating system. So in case if you're going for a 16 GB or below, I would recommend you go with the noob slide. But make sure you keep the bare minimum of 16 GB in case if you're working with Raspberry Pi. But do not mistake me when I say use a 16 GB memory card. You can install it on an 8 GB as well. But again, the operating system has less memory to work with. So at least go for 16 or higher. 32 is what I would recommend to. So once you download this zip file, or you can even download it via torrent. Okay, but I would recommend download it as a zip file. Let me show you the file. So this is the noobs file. Let me extract this. Okay, it may take some time. Okay, it's about a 1.5 GB file. Okay, the lights version is slightly lower in comparison, but this is something that I would recommend in case if you're working with Raspberry Pi. Okay, so I have my noobs folder here. So what you need to do is that you need to copy everything inside the noob folders and then paste it inside the SD card. Okay, make sure you're not directly copy pasting the folder that you have extracted. So what happens is if you do that, it does not actually recognize the operating system as part of the Raspberry Pi. So copy everything that you have extracted and then directly paste it inside the SD card. Now again, this is why I recommend that you use a high-speed memory card, because in case if you're not using it, then what happens is that it takes a lot of time with respect to fetching the data. Okay, now as I had mentioned, if you're going for a memory card for your Raspberry Pi, you can use something like a 16 GB at least and make sure it has a high transfer speed. So this in turn will give you a lot of memory area to work around with, as well as I would recommend you take something like a class 10 memory card that is available in the market today. So these have a very good read and write speed ratio. So definitely this is something that you should consider while you're getting a memory card for your operating system. Okay, now once we're done copying with this, let's go on to install this memory card onto our Raspberry Pi and let's begin the installation process. Okay, so now we've successfully copied all that is needed for our operating system. So safely remove this, make sure you're ejecting it safely. Because sometimes what happens is if you do not safely eject it, the files get corrupted before you load it into your Raspberry Pi. This is a certain issue with respect to the memory cards. So just eject this. Okay, so this is my Raspberry Pi. And if you actually flip it over, this is the slot where you have to insert the memory card. Now we've copied the noobs folder into this memory card. Again, let me just insert this into this and let's begin with respect to the installation process. Let's begin installing this memory card onto my Raspberry Pi and start with the setup. So let me just turn on my Raspberry Pi. Okay, so this is the screen I'm getting by default. Okay, now what happens is the installation steps initializes. So the Raspberry Pi is getting loaded. Okay, now there are two operating systems that are present here by default and we want Raspbian. So let me just select Raspbian and click on install option present here. Now if you see here, it basically is telling me that it requires 4.5 GB. So this is why I was recommending you to get at least 16 GB or more. Because if I have an 8 GB memory card, if 4.5 GB goes off with the operating system itself, then there's not much memory left for me to work around with. Okay, now let me just click on install. Okay, just before I do that, in case if you are using a different language or if you want to use a different keyboard as well, you make sure you're specifying that. Okay, so there are different languages present here, so choose the corresponding language as per your requirement. Okay, once you've selected that, just click on install, and this is just basically going to ask you whether you want to format your data and install the operating system on top of this. So click on yes and the installation process has begun. Now it may take some time, so I request you to be a bit patient because this is an operating system installation process. So please be a bit patient and hope you have fun meanwhile. Okay, so now as you can see, the operating system installation has completed successfully. Once you hit on OK, it's going to ask me whether I want to reboot or it would automatically reboot as well. Okay, so yeah, it's automatically rebooting at this point. Okay, now as you can see, the Raspberry Pi operating system has successfully been installed. Okay, so this is what your Raspberry Pi operating system would be looking like. Okay, so this is Raspbian as such. So there are different operating systems that are available today for you to install that we have discussed already. So let me go back to my slide and let me just summarize the installation process again. Now, if you see here, we started by downloading the noobs folder and then we went on to extract the folder and copy it into the SD card. Okay, make sure the SD card is empty as well. Once you're done with this, insert it into the SD card slot and then we have completed with respect to the installation process. Okay, now that we've installed Raspbian on Raspberry Pi, it's time we begin with the demo for this session. Now what we're trying to do is that we're trying to build a weather detection system to get the real-time weather analysis. Now, when we talk with real-time analysis, it basically is the pressure, temperature, and humidity. And what we want to do is that we want to get a live mobile notification for this. So for that, we'll be first using Sensat board, which will help us measure the various metrics like temperature, humidity, and pressure onto a Raspberry Pi. Then we'll use Raspberry Pi to transfer this data and display it on the Sensat as well. So we'll just be displaying the temperature as of now on the Sensat. And finally, we'll be using InstaPush API and Python program through which we can send this notification across the internet to our mobile application. So let's begin this demo part. First, let me show you what Sensat is and how you can assemble Sensat on Raspberry Pi.
Okay, so this is my Raspberry Pi unit, and this was what I was referring to. This is Sensat board. Okay, now if you see, this is a simple additional board that you can add on top of your Raspberry Pi. Okay, now it's quite simple, but how it's different is that in comparison to your Raspberry Pi, there is an 8x8 digital LED display present here. So you can use this for various different purposes as per your requirement. Okay, now it simply sits on top of the Raspberry Pi. Okay, just make sure the alignment is correct, and once you've done with that, just push it on top and the pins would merge accordingly. Once you do that, you can just place the 4 screws across the different ends and tighten it up. And once you're done with this, you can integrate and use the Sensat for various different purposes. We'll use Sensat to measure the temperature, the pressure, as well as the humidity across in this room that is present. Okay, so this has different sensors present on it, and we'll be using them for today's demo. Okay, so let me just put this up, and once it's all set up, let's go back to our demo and let's begin with understanding the programs before we begin the execution.
Okay, so moving on, now that you've understood about Raspberry Pi, Sensat, and we've also installed Raspbian on our Raspberry Pi, let's move forward and start with respect to today's demo part. So again, going back, just to remind you, we're trying to create a weather control system wherein we're trying to measure the temperature, the pressure, and the humidity around the sensor as such. Okay, so the first thing we're going to do is that let me just connect to my Raspberry Pi. Okay, so this is my Raspberry Pi interface. Now let me just show you the program as well. So I've divided the actual program into 3 parts so that it's easier for you to understand how this program works as such. Now the first program that we are going to execute is the sensing environment. So this is a simple program that's going to sense the environment variables, that is the temperature, pressure, and humidity, and then it's going to correspondingly display these values on the Sensat LED display panel. Now let me explain this program to you one by one. Now firstly, we need to import the variables, the values on the Sensat. So for that, we're going to use this line, from sens_hat import Sensat. So this will give me the corresponding values from the Sensat to my Raspberry Pi interface. Then I'm also importing time. Now the main objective of time is to help me keep a log of all the values that I'm measuring. Okay, so that we'll be seeing a little ahead. After that, I'm going to assign the Sensat values to a variable known as sense. Okay, so through this variable, I'm going to correspondingly relate to all the values coming from the Sensat. Okay, moving forward, we have written a while loop, and this is an infinite while loop. So it's going to continuously measure the temperature, pressure, and humidity, and it's going to correspondingly be displayed on the Sensat as well. Okay, so let me help you understand how the temperature, humidity, and pressure are measured. Okay, so what you need to do to measure the temperature is use the function sense.get_temperature. So this function, that is get_temperature, will give me the temperature value measured by the Sensat in degrees centigrade. And here what I'm basically doing is that I'm just converting it into Fahrenheit. Okay, so the value in degrees centigrade into 1.8 plus 32 is just a Fahrenheit representation of the current temperature. I'm using a round function to round off the corresponding value. I don't need any decimal point values here. I want a whole number. So what I'm doing is that I'm using a round function. And once I have the temperature, then I'm going to be storing it inside a temp variable. Okay, similarly, we're going to use sense.getHumidity and sense.getPressure to get both the humidity as well as pressure and store it in humidity and pressure variables as such. So basically, I have all my 3 variables that are needed. Now what I'll do is I'll create a string called message, okay, into which I'm going to store the temperature, humidity, and pressure with a specific notation. So T is going to be equal to the temperature, H is going to be equal to the humidity, and P is going to be equal to the pressure. Now comes the part where I have to display this value onto my Sensat display screen. Okay, so here I'm going to use the function sense.show_message. So this is basically a call through which I can send any message to my Sensat display screen. Okay, now here I'm just passing the message with respect to the temperature, humidity and pressure variable, and then I'm also defining a scroll speed. Now this is something that you can play around with. If you want to have a faster scroll, you can modify it. I've chosen a 0.08 scroll speed. Then the other two factors are the font color and the background color. Okay, now the text color I have set as 200, 240 and 200. Now if you can guess, these are basically the RGB values for the corresponding text color. So this is something that I have set as per my requirements. You can play around. As well as background color is something that I have set to 0, 0 and 0. Okay, so you have the complete freedom to modify this as per your interest. I would definitely recommend that you try playing around with this to get a better feel of how it works. Okay, now what I'm doing is that I'm putting my system to sleep for 4 seconds. This is basically to introduce a delay between the measurement carried out from the sensor. Now if I don't do this, since it's a continuously running infinite loop, it's going to keep measuring it one after the other. So I want a simple delay between the measurement. So I'm putting the system to sleep for 4 seconds. After that, what I'm doing is that I'm opening a file called weather.txt. Now here I'm going to create the log. Into this file, I'll take the present time and then pass the message as well. So these both, with respect to the present time as well as the message, are going to be stored in form of a log. Okay, so in case in future if I want to refer to the measurement, this is something that will be really helpful. Finally, I'm also going to print message on my console. Now this is something just for our understanding as well. We'll be seeing it on different places. We'll see it on the console, we'll see it on the sensat, as well as we will be seeing it inside the log file as well. Finally, I'm closing the log and then I'm putting my system to sleep for 5 seconds. So these sleep delays are just to ensure that the consistent values are being measured in a regular interval and there's no hindrance with respect to that. Okay, I hope you guys are clear with this because I'm going to go on to execute this program. So let me open my console. Okay, here let me write the command for executing a Python program, and it's very simple. It's just Python followed by the file name. Okay, now in our case it's sensing environment. Okay, so let me execute this. And now if you see, the values are being computed, and on the sensat the values are being shown as well. So you can see here the change with respect to that. Okay, firstly it showed me all the temperature, humidity and pressure, and now it's already come on the console as well. Similarly, it's going to have a simple delay, and then you can see already it's showing me the next values on my sensat, and it's going to be stored in a log file, and then it's going to come onto my console. So very interesting, right? So definitely you can play around with respect to the font, you can play around with respect to the background color, as well as if you are interested, you can try bringing different temperatured items near the sensat to see the variation with respect to that as well. Let's say if you have a glass of hot water and you bring it near the sensat, the temperature value will correspondingly change as well. Okay, so this is something that you can really experiment on and have a good understanding of how things work out. So let me just close this program and let's see the log file. Okay, so this is my weather.txt file. So I've taken different temperature measure variables. It's been logged from a long time that we've been trying this out on. So definitely there are a lot of values here. Okay, so let me just show you the latest value. So this is a range of values that I had just tried out some time back. So all the temperature and pressure log are being stored here continuously. Okay, and if we come down, this is the latest log that we have just created. With respect to the three values, this is the current status as such. Okay, so again, this is something that you can experiment on. I have just stored it because of my future reference as well. Okay, so I hope you guys have got a simple understanding of how you can connect to your sensat, measure the temperature, pressure and humidity, and also display it on the console as well as on your sensat. Now coming on to the second part. Second part is a slightly advanced version of the same program. Here we're trying to do something a little more apart from just seeing it on the screen. Okay, now I want to send an email with respect to all the logs that I have. Or let us say at a regular interval, I want to have an email which notifies me with respect to the present temperature and the current pressure and humidity. Now this is something that you can definitely use while you're working on a social experiment as such. Usually in laboratories, it's important that you always keep a check on the temperature, pressure and humidity. So this is something that you can try out. So let me show you the code. Alright, so here I'm just including something new as well apart from our previous code. Okay, now if you see, our previous code is still present here. I'm taking the temperature, I'm taking the pressure, humidity, storing into a message, and then I'm also printing that message. But apart from that, I'm using a few libraries which are very essential for mailing me this detail. Okay, so for that I'm going to use first SMTP library. okay, because your mailing protocols are SMTP based protocols. So these are something that I'll be using in case I need to send a mail with respect to all the details as such. So these are standard protocols through which I'll be communicating. Okay, now coming down with respect to what MIME is. MIME basically is an extension, a multi-purpose internet mailing extension, okay, through which I can send emails which support text characters, non-text characters, audio, video, images, and so forth. So sending a mail, this is an essential important library as such. Okay, moving on forward, let me explain you the code. Now, here we're repeating the same thing. We are also importing the time function, and then we are establishing a communication between the sensat and the program. Okay, so here first you need to specify the from address, that is from whose mail ID you're sending this. So I have created two test mail IDs. One is edurekatest11@gmail.com. So from this address the mail is going to be sent, and the address which is going to be receiving this is Edureka Raspberry Pi. Okay, so from this email ID I'm going to send a log with respect to the data that is measured from my sensat Raspberry Pi. Okay, then I'm going to use my MIME multipart function. From here I'm going to distribute my mail into multiple parts. So this is what your MIME multipart function will help you do that. So in my message part, the from is going to be the from address, that is from whom it is going. The to is going to be the to address, and the subject I'm defining it as temperature Raspberry Pi. So temp rasp. Then I'm measuring all the temperature as well as the pressure and humidity and storing it inside a message variable. So here what I'm doing is that I'm basically going to attach the message in a plain format to my message variable, which is going to be the details of the temperature and pressure. Okay, now let me come down and help you understand this part of the code. Now I'm going to establish a connection to my server. So I'm going to use a server variable wherein I'm establishing an SMTP protocol to Google. Okay, that is your smtp.gmail.com. So this is a standard mail protocol SMTP. For Gmail it is smtp.gmail. For other mails you can just replace the corresponding mail. And then you have the port number. So again, with respect to SMTP, this is a standard port that you would be using for communication, that is 25. Okay, then I'm going to start my server. So that is server.startTLS. Okay, once I start this, then I'm going to specify the login credentials. This is basically for authentication factor. So server.login, you have to provide the username and password. So my from address is my username and my Edureka API is the password for this email ID. Okay, once I've specified this, then what I'm doing is that I'm converting the message as a string. Okay, sometimes what happens is while you're trying to send this, it may not get sent as such because it has values also associated with it. So I'm directly converting it completely to a string, okay, and then storing it inside a variable known as text. Then I'm calling the function sendMail, through which I'm specifying from which address it is going, to which address it should go, and the text which is part of it. Finally, I'm quitting the connection between the server. I hope you've understood till here with respect to the program. Now it's time we execute this program. Okay, so let me call Python email.py. Okay, so now what it has done, now it's connecting to my server, that's the delay here. Okay, it's measured the temperature, it's measured the humidity as well as measured the pressure, and then it's going to send a mail. So let me show you this mail ID as well. So as you can see here, I've already received a mail from Edureka test11. It's called temp rasp that we had set, and it's given me the corresponding value of temperature, humidity and pressure. So this is what I was referring for. So you can do this across. Now let me just show you my sent box as well. Okay, now if you see in your sent box, I can actually see that this mail has been sent. So there are two ways for me to verify this as well. So this is something that is really helpful for me. Now coming back to my Raspberry Pi, let us now see the final program in which we're going to incorporate this and do a little more. So let me explain you the code a little more better here. There are a few things new here. So first you have PyCurl and JSON being imported. Now PyCurl basically is going to help you establish a connection between your API. So we're going to use an API through which I'm going to pass my data. So for that I'm including PyCurl here. Apart from that, you have your string IO, which is a standard string input output management package, and you have your RPI.GPIO. So that is Raspberry Pi's general input output. I'm just referring to it as GPIO. Okay, so moving forward, whenever you see GPIO, it is the general input output from the Raspberry Pi. And then you have the similar function, you have sense_hat from sensat and time function. And I'm establishing a connection here as we have done earlier between my sensat and my application, and I'm clearing the screen on sensat. Now what happens is sometimes if you've executed a program before and you've stopped the execution of the program. Then what happens is the display will still have the remaining data present on it. It stays stuck on the sensor. So before we move on to with respect to a program, we'll clear the data out. Okay, so that's what sense.clear does. Now here there are two things that are present here, hot and cold. Okay, now why they're being used, I'll come back to that a little ahead. Okay, apart from that, there's also a new variable known as push message. So we'll be talking about this also when we come down later, and you'll understand what the push message is used for. Now let's try to understand the code which will help me display numbers on my sensor. Now you might be wondering, if I have already displayed number and data on my sensor, why do I need a separate part of this code? Because here we're trying to do something different from what we have already done. So here firstly what we're doing is that we are setting an offset from the left and the top. Let me go back to my presentation here. Okay, now here this is the standard program that we were talking about, but let's see, this is what we need. Okay, so this is what we're going to explore ahead. Now this is my actual sensat. Okay, this is an 8x8 LED display function. Okay, so here what I'm going to do is that I'm going to eliminate the first column and the first two rows from the top. Okay, so this distinctively will give me a 6x7 matrix area remaining with me. Okay, this is where I'm going to do all my operations from now onwards. So this is something interesting, and I'll help you understand why I'm taking this region. Now before we move on, let's take a simple look with respect to the code present here. Okay, now before I do that, let me try to help you understand why I've taken a 6x7 matrix area. Now this was the remaining area. I have divided this remaining area into two parts. Okay, I'm just going to give a gap of one column between these two, and the left hand side is going to represent the temperature or the value in tens place, and the right hand side segment is going to give me the value in ones place. So this basically is a 3x5 matrix wherein I have 15 positions to play around with. Remember this number again, this is 15 areas that I can play around with in a 3x5 matrix. Now let's go back to our code. Now let me help you understand how it works. Now I have basically 10 numbers with me. Okay, so each one is going to have a specific way of representing in a 3x5 matrix. So that's what I have written here in this number matrix as such. Okay, so each of the line is a representation of a corresponding number in a 3x5 matrix, and this 1 and 0 basically is the configuration for the LED to be either turned on or turned off. So normally when we write 0, the first line will always be full. The first three numbers are 1. Okay, then you have 1 0 1. Okay, again 1 0 1 1 0 1, and my last three numbers will be again 1. So as and when you represent 0 in a normal form, this is how you do that. So it may not be so clear to you right now. Okay, so what I would recommend is, before you try to understand how each of the numbers are displayed, set an offset on your sensor. There, try playing around with respect to different values to understand how you can represent each of the numbers. Once you've made 2 or 3 mistakes, then you'll get a clear-cut understanding of how each of the numbers can be displayed. Now this is for a 3x5 matrix. Tomorrow you want to try it across the 8x8, you can do that as well. So definitely make sure to try out, make mistakes, only then will you learn. Okay, so each of the line is a representation for a digit in a 3x5 matrix. Now let's try to understand how we can display a single digit. For that I'm going to define a function called show digit. Okay, so this is the function. It takes a value as an input. Okay, it takes a value for xd. Okay, xd is the x coordinate for where the digit has to be present. Yd is again the y coordinate as to where the digit has to be represented, and the last is a simple RGB value present here. Now first thing what I'm going to understand is that I'm going to compute the offset position. Okay, why do I need to compute an offset? Because each of the numbers are present in different rows of the column. So I need to understand which is the present number and which value do I need. So for that what I'll do is, the incoming value into 15 will always put me at the start of that row. Let's say the value is 3. Okay, so 3 into 15 tells me that I need to move 45 positions. So as I said, each row has 15. So 15, okay, then I have 30 in the next row. Okay, and once I'm done with the 45th transfer, then I'm here. This is the standard representation for 3. So I have this complete row at my disposal. Presently I'm pointing to the start of the 3 value. Okay, so this is something important to remember. So this is why we are computing an offset by multiplying the value into 15. So I have the complete access to this row. Okay, now we'll try to execute a for loop through which I'll place these values into the different parts of the LED display. Okay, now see, I have 3 cross 15 area, so I need to identify in which area should which value come. That is, which LED should be turned on. I have 3 rows and 5 columns, so I need to identify this. Let's go back. Now the first thing that I'm going to do is that I'm going to compute xt. Okay, xt basically is going to be the value of p modulo 3. Okay, this basically is going to give me value of 0, 1 or 2. Okay, so if you go back to our presentation, it's either going to start from this 0th position, or it is going to be in the first position or in the second position. Okay, similarly in the left hand side also it could be this 0th position, first position or second position. So basically we are dividing this. That's what you need to understand. Okay, coming back, let me just remove this. Okay, similarly I'm going to compute my y of t. Y of t basically is to help me understand which value should I take from this complete row. So this will basically start from 0 and go all the way till 14 as such. Okay, so it will basically represent which column value should I take. Okay, so I hope you understand. From this, which column value should I keep taking for my next value. Once I have this, then what I'll do is I'm going to call the sense.setPixel. Remember how we had called sense.showMessage? So therein we had sent a complete message. Now what we're doing is that we're just sending each of the pixels individually as such. Okay, so we're going to use the x coordinate, okay, which is going to be my xt plus xd. Okay, remember this. Okay, we'll define xd little ahead, but just keep this in mind. Xt plus xd is going to give me the x coordinate, yt plus yd is going to give me the y coordinate, and then basically my RGB number comes. So here I have just done a multiplication of p into r. So whichever I want, I'll just convert it accordingly. Okay, now comes the choice of when you have to display 2-digit number. So instead of going back to the same function, I have defined a new function which is called show number. Now show number is actually the original function that will be called, because the temperature measured is most often a 2-digit number. So this is where the actual code was going to start from. Okay, show number takes 4 values. It takes a variable called val, which is the present temperature. I have my RGB value, as well as I'm going to begin the function here. Firstly, I'll begin by taking the absolute value of the given input. Okay, when I say absolute value, I am basically trying to identify the number present in the tens place. Okay, so this is what absolute value will be. Whatever the digit is present in the tens place, I'm going to store it in my abs underscore value. So that I'm just providing it here to the tens place. Then let me also identify what is in units place, and this is simple mathematical operation where I divide the number by 10. I'm going to get a remainder, and that's what I want. So I'm going to use a modular division. So my absolute value divided by 10 is going to give me the units place as well. Now what I'll do is I'll run an if condition. So here what I'm going to do, if the value is greater than 9, then I'm going to call the show digit function which I had defined earlier, and I'm going to pass the tens value. Okay, the value present in the tens place. So, and then I'm going to also pass the xd and yd. In this case, xd and yd is going to be the offset left and offset top. Why? Let me help you understand here. My offset top is going to be with respect to this position. It's going to start from here. Okay, so it will point to the third row. Okay, my offset left will point to the second column here. So I know that this is where my tens place has to come. So that's why I'm passing it here. Okay, I also am going to pass the standard RGB value that I have got input here. Then for a second time, I'm going to call the show digit function, wherein I'll pass the units place, but with an offset of additional 4 spaces. Okay, so this, coming back to our segmentation, this is going to be 4 positions from our left. So offset left is going to give me the first place, but offset left plus 4 is going to be the start place where I have defined for my units place. When I say from top, it's both going to be the same because I'm not separating with respect to different levels. So I'm just going to change with respect to my offset left. Okay, so that's the only difference present here. Now coming down, we are computing the basic temperature, the humidity and the pressure, and then storing it into a message string. Now comes the place where I need to do my actual implementation. Now if you remember our problem statement, we have to send the pressure, temperature and humidity as a notification on our mobile device. Okay, so for that I'm going to use InstaPush, which is an application through which I can send notifications across my mobile. So my Python application, that is the final application, will communicate to InstaPush, and that will in turn communicate to my mobile application that on which I have configured it. Okay, so the notification will be received on my mobile application. Now coming down, let me remind you again why we are using this. In a real world scenario, this is something that is being used by NASA. Okay, there they're using it to identify if the exterior temperature is falling between a specific range, or even let's say if there's a change in the pressure inside the cabin, or if the humidity is too high. So all this can be measured and you can get notified with respect to any change that you want. Okay, now coming back to our program, this is why I have defined a range of cold and hot. If it falls below 37 degrees, I want a notification. If it goes beyond 40, I want a notification. So this is my range. By value, it should either be only 38 or 39. Okay, so this is why I'm using cold and hot variables. Now let me help you understand how the InstaPush application is working. For that, let me open my browser and show you how you can configure InstaPush for your Raspberry Pi application. Okay, so this is my InstaPush homepage. Okay, now first thing what you need to do is that you need to begin by creating a user ID credential here. And it is very important when you logging into your application, you use the same credentials. So make sure you do not lose this because it's very important. Only if you use the same credential will you get this notification. So remember that. So you have an option to sign up for free as well. Okay, all you need to do is provide your username, provide your email address, and then specify a password. Now let me just log in. Okay, so I'm just logged in. Okay, now here you can see there's already a timeline because I've already configured this application. Let me help you understand how you can do this. Now in my application, I already have a temp notify application, okay, which we'll be using as part of our understanding. Okay, firstly, let me click on add application. Now once I do this, I need to specify a name. So let me just call it sample. Once I click on sample, once I press add application, sample gets created. Now it is asking me to add event here. So click on add event. So let me call this temp rasp, okay, and then tracker would be message. Make sure you hit a tab here after you specify whatever it is that you're specifying, and here push message will be message. So make sure it's present inside curly braces whatever you're specifying here. Once this is done, just click on add event and this event is going to get added. Okay, so the event has been added. Now it's time I help you understand why I had specified message there. So remember, let me go back to my code. Remember we had defined something known as push message. So this is why I have defined message here. So this is what is going to be sent between my final program application and my InstaPush application. So this is why we had defined this variable earlier as well. Okay, now coming down with respect to this. Let me go back to my InstaPush and let me help you understand what all do you need before you move ahead. Okay, just go to the basic info tab, and here there are two things that you need. Okay, first you need your application ID and then you need the application secret. So this is very similar to how you have a user ID and password. So this is what you're going to use in case you're working with an application. Okay, so make sure you note this application ID and the corresponding application password. Now if you come back to my program, you can already see I have mentioned the application ID as well as the application secret, and here the push event is to my temp notify. So this was the previous event that was already set, so I'll be referring to that as well. Now what you need to do is that you need to use curl to post whatever data that you have to the InstaPush API. So for that you're going to use pycurl.curl function. Okay, and this in turn will help you communicate between your application and InstaPush. Okay, so all the communication is going to be through a variable called C. Now C.setOpt. Okay, here what I'm going to specify is that I'm going to specify the URL first. Okay, the URL is going to be https://api.instapush.im/version1/post. Okay, there's also another alternative URL which is https://api.instapush.im/post itself. Now in case the other is not working, you can use this or vice versa. Okay, moving forward, I need to set up the customer headers basically for my authentication and content type specification. Okay, so for that you're going to use the command c.setTop followed by c.http header. Then I'm going to specify x-insta-push-API ID plus my app ID, which I have specified earlier. So this will help me identify to which app this has to be pushed. Okay. The next is going to be x-insta-push-app secret. So basically the app secret, your password in this case. Okay. Then comes the content type. That is, what type of content are you going to pass? So this is going to be application.json. So I'm basically going to pass a JSON file to my API. Okay. So I hope you guys are clear till here. Okay. Now what I'm going to do is that I'm going to define the function through which the message is going to be passed. Okay. So here what I'm going to do first is that I'm going to use a dictionary structure for passing the data as JSON in my post function. So JSON-field is going to create a dictionary, and through that I'm going to send this data. Okay. Now what I have to do is that I have to specify the field values. So first comes the event, okay, which is basically what event I need to relate to. Then comes my tracker. Now I have not specified any tracker as such. Then comes my message, wherein I'm going to pass the push message. Push message basically is the temperature, the pressure, and the humidity as such. Now if you want, you can print this, but I'm not going to print it here. Finally, I'm going to use json.dump to make a JSON file and going to assign it to post fields variable. Okay, so post field is the variable which I'm going to pass to my API. Okay, next, to send your JSON file with post, use the following command: c.setTop, okay, inside which you're going to specify c.post field, and you're going to pass this post field, which is the JSON file as such. Then if you wish to capture the response, then you can capture it inside a buffer. So for that, I'm also going to use a buffer.write operation, and this can be done with the following command: c.setTop, inside which I'm going to write c.write function and buffer write. That is, the write back has to be into my buffer. Okay. Now if you want to be updated whether the post has been sent, then you can use the following command, that is c.setTop followed by c of 𝐶_verbRows. So this will make sure that I am getting posted on my terminal with respect to the communication. Finally comes our operation of checking the temperature. This is very similar to what we have done earlier, where we are running an infinite loop. I'm measuring my temperature in degrees centigrades, I'm measuring my humidity, measuring my pressure, storing this value inside a message variable, and then putting it to sleep. Simultaneously, I'm also writing into a log file, and this is going to be stored with respect to the present time. Okay. So till here, I hope you guys are clear. Now comes the part where I've identified my temperature. I'm just making sure it's an integer, and then I'm going to call my show number function. Remember, we had defined a function based on which it is going to be displayed on my Raspberry Pi. So this is a call to that function. Okay, once I've done with this, I'm going to store it into temp1. Then I'll make sure that I'm writing it into my file, and then comes the interesting part. If my present temperature is either greater than or equal to the hot message, or if it is lesser than or equal to a cold temperature that we have defined. Remember the two variables we had defined earlier? This is where they are being used. Okay, the push message will start with either if it's hot or if it's cold. Following that would be the present values. Okay, the pressure, the temperature, and the humidity. Okay, then what I'm doing is that I'm going to pass this push message to my P function that I have just defined. So basically it'll first convert the push message into a JSON data, and then it'll pass it through the communication. So this is what is happening here. Okay, same thing will happen in case the temperature falls below the cold range as well. Okay, then I'm going to create a JSON file and then call c.perform. So this basically will initiate the curl operation to start. Finally, to capture the response from the server, you can actually use the buffer range. Okay, so with this we've come to a conclusion. Let me just show you the final part of this. Okay, so make sure that you're closing the communication through curl. So use c.close. Okay, this will ensure that the communication done through curl is closed, as well as you ensure that the general purpose input output is cleaned up so that new values are being taken in. So now let's execute the final program. That's Python final program.py. Okay, now as you see on the Raspberry Pi, it's showing me that it's presently 35 degrees centigrade. Okay. Okay, I've started getting notifications on my phone. Let me just share this phone screen with you. Okay, and you can see there's a variation with respect to the temperature shown on the Raspberry Pi as well. Okay, let me show you first my phone screen. Now if you see here, it's actually showing me multiple notifications being generated. Okay, it's showing me that it's cold presently, and here's the complete list of the temperature notifications. So I'm getting a constant notification with respect to the change in temperature. So you can see it's continuously being generated here as well. So this is something that is really helpful when you're working around with respect to a real-time scenario. So like I said, NASA extensively uses this for their own purposes of measuring the temperature, pressure, both in their scientific research area as well as the shuttles and space stations that they use on. Okay, so with this we come to a conclusion of our demo session. Okay, let me go back to my presentation and let's just have a summary of what we've discussed as part of this session. Okay, so let's just summarize what we've discussed as part of this session. We started off by first understanding what is IoT, then we moved on to understand why we need IoT as well as the various benefits and features of IoT. And then we started with the demo wherein we installed Raspbian on Raspberry Pi, and finally we created a weather detection system using Raspbian and Sensat. So with this, let's end this session. So with this, thank you.